Alright, let's start with question A. For question A, we need to take total differential of the general implicit. What is general implicit form? General implicit is where we need to take equation before the equal sign. So we do have two equations, f1 and f2. Let's do differentiation for both of the question. After the differentiation for equation f1, we have found out the answer as df power of 1 over dy times dy plus df power of 1 over dr times dr plus df power of 1 over dm0 times dm0 plus df1 over dx0 times dx0. For second equation, we have found out the answer as df squared over dy times dy plus df squared over dr times dr plus df squared over dm0 times dm0 plus df squared over dx0 times with dx0. So that is the general implicit form for both of the questions. Alright, let's move on to question B. For question B, we need to take the total differential of the specific form of both equation above. What is specific implicit form? Specific implicit form is where we need to take equation after the equal sign. So we do have two equations. Let's differentiate the equation. We have found out the answer as dl over dr times dr plus df power of 1 over dxo times dxo minus ds over dy times dy minus with ds over dr times dr minus dz over dy times dy minus dz over dr times dr is equals to 0. For the second equation, we have found out the answer as dl over dy times dy minus with dl over dr times with dr minus dm squared over dm0 times dm0 is equals to 0. So we have found out the specific implicit form for both of the equations.
The general case equations represent the total derivatives of two functions f1 and f2 with respect of multiple variables y, x, r, m, and x. Each equation is a sum of partial derivatives of f1 and f2 with respect to these variables multiplied by the differentials of the variables. The specific case equations simplify the general case by setting some of the variables to zero or constants. They represent the total derivatives with respect to fewer variables and include additional terms for the derivatives with respect to I, S, and Z. The general form equations describe how the functions f1 and f2 change with respect to the variables y and r. The changes in f1 are influenced by the negative change in s and z, while the changes in f2 are directly related to the change in L. For the specific equations, the first term represents the combined effect of change in s and z with respect to y multiplied by dy. The second term includes the effect of change in I, S, and Z with respect to r multiplied by dr. The third term includes the effect of change in L with respect to y, x, and r multiplied by their respective differentials. The right-hand side of the equation is a combination of constant and differentials indicating a relationship between these variables. The matrix form Jx equal to B. Left matrix J. This represents the coefficients of the system of equations. Each entry corresponds to the partial derivatives of constant from the original equation. The first row includes the derivatives of s and z with respect to y and r, the derivative of I with respect to r, and a constant -1. The second row consists of the derivatives of L with respect to y, x, and r, along with a term dm. Column vector x. This represents the variables of the system. The entries are differentials dy, dx, dr, and d times x p0. The right vector b. This represents the resulting vector after applying the matrix J to the vector x. The entries here are the derivatives of f1 with respect to x and a constant 0. This matrix contains the partial derivatives of the function s, z, and L with respect to the variables y and r. The determinant is found using the standard method for 3 times 3 matrix, which involves summing the products of the diagonal elements and subtracting the products of the off-diagonal elements. The calculation of the J is shown step by step. Determinant of J equals to negative times negative times negative minus positive times negative equals to positive minus negative, and the answer is positive. So this indicates that the determinant J is positive.
Calculation for dy with respect to dxo, g1 equals to dy over dxo, which will equals to metric form of positive 0 negative negative, which will the final answer will be positive. As for the calculation for dr with respect to dxo, j2 equals to dr over dxo, which will into a metric form of negative positive negative 0, which will the final answer will be positive. Therefore, this analysis confirms that higher exports positively impact both income and interest rate, reflecting great economic activity and increased demand for money in the open economy. An increase in autonomous export XO leads to an increase in both income Y and the interest rate R. This result aligns with economic intuition where higher exports boosts the economy raising income and the increased demand for money raising interest rates.
Question 2a. Partially differentiate Q with respect to PS. Equilibrium quantity equals to E plus F in bracket A plus E plus CPS minus DPC plus GPI divided by F plus B minus GPI. So now we will partially differentiate Q with respect to PS. So del QQ divided by del QPS equals to del Q divided by del QPS equals to E plus F in bracket A plus E plus CPS minus DPC plus GPI divided by F plus B minus GPI. Del QQ divided by del QPS equals to del Q divided by del QPS equals to F in bracket of A plus E plus CPS minus DPC plus GPI divided by F plus B. So F divided by F plus B times with del Q divided by del QPS in bracket A plus E plus CPS minus DPC plus GPI. So del Q divided by del QPS in bracket A plus E plus CPS minus DPC plus GPI. Del Q divided by del QPS F in bracket of A plus E plus CPS minus DPC plus GPI divided by F plus B equals to F divided by F plus B times C equals to FC divided by F plus B. So now del QQ divided by del QPS equals to 0 plus FC divided by F plus B equals to 0 equals to FC divided by F plus B. Del QQ divided by del QPS equals to FC divided by F plus. Question 2. Referring your finding in A, state the direction of the relationship between Q and PS. The answer is the partial derivative del QQ divided by del QPS is FC divided by F plus B. Since F, C and B are all positive constant, the fraction FC divided by F plus B is positive. Therefore, Q is positively related to PS. This means that as PS the price of substitute increases, the equilibrium quantity Q also. Question 2. Question C. Briefly explain the effect of change in PS on Q. The answer is the effect of a change in PS and Q is captured by the positive partial derivative FC divided by F plus B. This indicates that an increase in the price of a substitute good PS leads to an increase in the equilibrium quantity of the commodity in question. In economic terms, if the price of a substitute good rises, consumers are filled to switch their consumption to the commodity in question, leading to an increase in its equilibrium quantity. Conversely, if the price of the substitute falls, consumers might switch away from the commodity, leading to decrease in its equilibrium quantity. Thank you. Question C. Brief.
Audio Jungle.